Hello Geometry, we're back again, video 3, 21 through 30. Alright, number 21, which quadrilateral would be carried onto itself after a reflection over the diagonal AC? Carried onto itself, that means if you make the reflection, then it's actually sitting on top of itself. It will be the exact same reflection. So I feel like the best way is to just, because it's standing out to me that letter C is the answer. And so I feel like just showing you that, and then it will make sense what carried onto itself might mean. So saying the diagonal AC is where we're going to make the reflection over. So if I imagine, say, this right side reflected over that blue line, it would be sitting on itself. And so I could take the left side and make it on the right, or the right side on the left, and it's carried onto itself. It's sitting on itself. So letter C here, but I want to show you why the other ones are not, and it was standing out why that was the right answer. So look at AC. If I took this side and I made that reflection, well, I did kind of a bad job there. That side, there we go. So it's not sitting on top of itself. Or if I did this side, it would be like that, not sitting on top of itself. And all of these are doing that. So here's diagonal AC. This side would go something like that. And here, this side would, oh, I did a bad job, didn't I? About like that. So, as you can see, letter C. Which of the following statements is true? All triangles are congruent. That seems silly. All triangles are congruent. Congruent means the same exact shape, totally equal in every way. So here's a right triangle, and here's an equilateral. They're not congruent at all. So why would all triangles be congruent? You can draw a lot of different, that was a horrible triangle, a lot of different types of looking triangles that are not congruent. So that one's a no. All congruent figures have three sides. That's another silly one. What if I have two congruent rectangles? Those don't have three sides. Or squares, or octagons, or you can have congruent anything. So they definitely don't have to have three sides. If two figures are congruent, there must be some sequence of rigid motions that maps one onto the other. Mapping a rigid motion. So that means I'm just going to make up a shape, maybe that right triangle again. So if I have a congruent right triangle, that means if I take, so the rigid motion, oops, oh man, I'm really messing up. The rigid motion means if I take one of them and I move it onto the other, it would be sitting exactly on top. And that's what the rigid motion means. And so if two figures are congruent, you can move one on top of the other and it would look exactly the same. That's what congruence means. So we've got letter C there being a true. And let's see what D says. If two triangles are congruent, then they must be right triangles. Well, that's silly. I could have two equilateral triangles that are congruent. It doesn't mean that they have to be right. So there we go. Number 23. If triangle CED is congruent to triangle QRP, which of the following is true? All right, so this is about the order that they say the letters in is very important. If they called the first triangle CED, C is the first letter, so it's going to be corresponding to Q. So C would be congruent to Q. E, the second letter, would be congruent to R. And D, the third letter, with the third letter on the second triangle, D and P. So I'm looking for the choice that says C is congruent to Q, E is congruent to R, D is congruent to P. And letter A. Number 24. Refer to the figure to complete the congruent statement. Triangle ABC is congruent to... All right, let's look and see what we have here. I'm going to highlight triangle ABC. Where's the triangle here that's congruent? So I'm just going to notice the markings. One slash, so BC is congruent to DC, and then 2 slashes here, so those guys are congruent, and then 3 and 3, so those guys are congruent. So highlighting the congruent triangle over here would be that guy. So now we just have to say the letters of the blue triangle in the right order. A is congruent to E, corresponding and congruent. Next letter B. B is congruent to D, and C is congruent to itself. So E, D, C, letter B. Number 25. In the figure, angle H is congruent to angle L. I'm just going to mark that on there. And HJ, I'm going to make those marks a little smaller. HJ is congruent to JL. HJJL. Which of the following statements about congruence is true? Okay, so they're saying the left triangle is congruent to the right triangle, and then listing one of our congruent statement, angle, side, 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 angle, side, or side. The last two are both side, angle, side. But the order of the letters are different. So let's think this through and figure out how can we make the two triangles congruent. All we have right now is an angle and a side. That's not enough. We need another thing. Either a side or an angle. There's nothing in this diagram that tells me anything about any more sides, but I'm noticing our two crossing segments there, and that creates vertical angles. So we've got those two being congruent because they're vertical. So what we have here is angle, side, angle. And that would be, and let's look at the order of the letters. H, I, J, and then L, K, J. H corresponds to L, I to K, and J to itself. So we've got letter A here, and it's the only one that said angle, side, angle. Determine which postulate or theorem can be used to prove the pair of triangles congruent. All right, we've kind of got to do the same thing here. That how can we say these are congruent? We've got one angle there. We've got 2 slash marks, so those 2 green angles are congruent. And then I'm noticing that each triangle shares that side. It's a side of the left triangle, and it's a side of the right triangle. So that would mean we have a side congruent. And now I've got to decide, is this angle, side, angle? What is this? I'm going to look at the order on the triangles. Like it goes angle, and then angle, and then side. Angle, angle, side. I was trying to say it's not angle, side, angle, because angle, side, angle is when the two angles are on either side of whatever side. So that would look like that. Angle, side, angle. Here we didn't have that. It would have to have been this side for angle, side, angle. So this one is angle, angle, side. Angle, angle, side. Letter A. Number 27. Which theorem can be used to conclude that triangle CAB is congruent to CED? Very similar to the ones we've just done. We have a pair of sides, we have another pair of sides, and we've got those crossing lines again, so we've got a pair of vertical angles. And so we have side, angle, side. Side, angle, side. Letter B. Number 28. In the figure, GAE is congruent to LOD, which they've marked. AE is congruent to DO, which they've marked. What information is needed to prove that AGE is congruent to OLD, the triangles, by SAS? So what would I need for it to be SAS? Side, angle, side. So side, angle, side is where the two sides are on either side surrounding the angle. So if I have an angle, it would be the two sides touching that angle, so to speak. So here, to have side, angle, side, we would have to, here's our side, here's our angle, so it would have to be that side. So AG and OL would have to be congruent for side, angle, side. Number 29. Which of the following sets of triangles can be proved congruent using angle, angle, side? So I'm going to draw angle, angle, side. That has to go in that order. Angle, another angle, and then a side. I can go around the other way. Angle, angle, side. And you can start at any, what if I started there? Angle, angle, side. So they just go in like a row along the triangle. So let's go through each of these here. We have two sides and an angle. That's not even two angles and a side. Letter B has three angles. That's not it. Letter C has angle, side, angle. That's not what we're looking for. Letter D, I hope this one works. Angle, angle, side. Aha. Kitty cat's making noise again. In the figure, identify which congruent statement is true. Then find the measure of angle TYW. TYW is that guy. Okay, so we have to say which triangles, what's the order of the letter, are they all the same there? Nope. So WTY is most of them, and then we've got to establish what the order of the letters is. And we have to find the measure of the angle. So I think I'm going to start with the measure of the angle. We know that these would be congruent because we have a side, and they share this side, which is the hypotenuse of each of the triangles. Remember, the hypotenuse is always the side opposite the right angle. And I think, oh yeah, it said it in the answers, by HL. So we know they're congruent, and they all say that. They're congruent by HL, hypotenuse leg. So if the two triangles are congruent, the two triangles being, we've got the top one and the bottom one, then that all of its parts are congruent. So this angle would be congruent to that angle, and those are the ones they gave us these expressions for. So if they're congruent, then we would be able to write 6x minus 26 is equal to 2x plus 6. And so we can solve this for x. I'm going to subtract 2x from both sides. That would leave us a 4x on the left-hand side. And now I'm going to add 26 to both sides. 6 plus 26 is 32. 4 times something is 32. That would be 8. And now I want to plug that in. And I could use either of them. It seemed easier to multiply 8 by 2 than 8 by 6, just for easier numbers, so I'm choosing this bottom one. 2 times 8 plus 6 is 16, excuse me, 16 plus 6, which is 22. So this little angle here, 22 degrees. We wanted this angle, TYW, and so we've got this one, which is 90, our little red one, 22. So if I take those numbers away from 180, since all three angles in a triangle add to 180, then we'll have our answer. So in my calculator, I'm going to go 180 minus 90 minus 22, and that is 68 degrees. So only one of them says 68 degrees. Let's check the letters. WTY is congruent to WXY. The letters are in perfect order. Number 30 is letter D, and that is it for this video. Have a nice night, I guess. There's going to be one more video.